Welcome to Module 00, the course orientation for Engineering Fundamentals for Building Automation. This course is based on Book 2 of the BAS Manager Handbook. The goal is not to memorize equations. The goal is to understand the physical systems behind the BAS screen, so every control decision is grounded in engineering, measurement, and field reality. In this orientation, we will review the course purpose, the learning path, how the modules are organized, how to use the videos and downloadable resources, and what is required to complete the course. Book 2 was written to close a common gap in the BAS field. Many capable professionals know how to edit graphics, discover devices, create points, and write logic before they have been formally taught the physics of coils, pumps, fans, valves, humidity, electrical signals, and pressure relationships. This course is the bridge. It does not replace an engineering degree or manufacturer instructions. It gives BAS professionals practical engineering judgment so they can troubleshoot from first principles and support real building performance. This course serves several audiences. Technicians can connect symptoms with physical causes. Controls engineers can write better sequences because they understand the equipment behind the logic. Commissioning providers can test whether the system is achieving the intended physical outcome. Facility managers can use the material to review design assumptions, evaluate risks, and develop staff. Students and career changers can use the course as a structured entry point into the engineering behind building automation. It is also important to be clear about boundaries. This is professional education, not a substitute for licensed engineering, safety procedures, codes, manufacturer instructions, or site authorization. The outcomes of this course are practical. Learners should be able to define the engineering problem before touching the software, preserve units and calculations, verify measurement quality, and use energy balance reasoning. They will work through airflow, hydronics, refrigeration, heating, electrical systems, sensors, actuators, IAQ, envelope behavior, and pressure-controlled spaces. Most importantly, they should learn to use calculations and data to support decisions, not to create false certainty. Good engineering documentation allows another professional to reproduce the reasoning. The course follows the book structure. Part 1 is Engineering Thinking, where learners build the habits that support the rest of the course. Part 2 covers air, water, and thermal systems, including psychrometrics, airflow, fans, VAV, hydronics, pumps, chillers, heat pumps, boilers, and steam. Part 3 moves into electrical systems and field devices, electrical fundamentals, motors, drives, power quality, sensors, measurement systems, actuators, valves, and dampers. Part 4 applies the knowledge to indoor air quality, envelope behavior, moisture, condensation, building pressure, critical spaces, design review, and applied case studies. This slide shows the module sequence. The order matters. The first 4 modules establish the method and physics. The next 7 follow air, water, and heat through the systems that BAS controls. Then we move into electrical power and field devices, because a control loop is only as reliable as its power, measurement, and final control element. Finally, we apply the concepts to IAQ, envelope performance, pressure relationships, design review, and integrated case studies. The tools library and capstone convert the learning into field-ready documents and decisions. Each module follows a consistent instructional method. First, we explain the concept, then we demonstrate it with a diagram or worked example. Next, we apply it to a BAS field decision. After that, we verify understanding with a knowledge check, calculation, or scenario. Finally, we reinforce the field takeaway. The videos are designed for avatar instruction with concise on-screen text and more complete explanation in narration. Every calculation should also include a units check and a reasonableness check, because the purpose is judgment, not just arithmetic. The study method is simple but powerful. Read the chapter once for the overall idea. Repeat the worked examples with your own calculator. Then compare the concept with an actual building system. Sketch the physical process before opening the BAS software. Discuss the questions with another professional, because explaining the idea helps you find weak understanding. Finally, record one change you will make in your field practice. This turns the course from passive watching into professional development. This is the field workflow learners should practice throughout the course. A value on the screen is a starting point, not the final answer. First, read what the BAS claims. Second, verify the measurement when the decision is important. Third, model the physical path: air, water, heat, pressure, electrical current, or mechanical movement. Fourth, test safely with a bounded and reversible action. Fifth, document and teach the lesson. The image shows exactly the kind of situation this course prepares learners for: a BAS value, a physical sensor, field verification, and a system response that must make engineering sense. The course assessments should confirm that learners can apply the engineering method in real BAS situations. Every module includes a quiz, scenario questions, and at least one calculation or interpretation problem where appropriate. The practical assignments are just as important: point audits, worksheets, design reviews, calibration plans, and troubleshooting scenarios. The recommended passing score is 80% for quizzes, the final exam, and the capstone project. The capstone should show that the learner can analyze a real building automation problem from measurement through corrective action and documentation. This course includes important safety and professional boundaries. Building automation can affect physical equipment, critical operations, indoor environmental conditions, energy systems, and human safety. The course helps learners ask better questions, verify measurements, communicate with engineers and trades, and make better BAS decisions. It does not replace site-specific procedures, manufacturer instructions, licensed engineering services, electrical authorization, combustion safety qualifications, or applicable codes. A strong BAS professional respects the limits of their competence and involves the proper discipline when needed. Before starting Module 01, learners should adopt the BAS Engineering Oath. Begin with the physical process before changing software. Verify measurements before trusting conclusions. Distinguish estimates from measured results. Identify assumptions and test whether they are reasonable. Document calculations so another professional can reproduce the work. Leave every system easier to understand than you found it. The next module begins the technical training with engineering thinking and the BAS method. The opening question is simple: what is actually happening in the building?